Hello everyone. In this video we're going to solve problems that deals with logic. What is actually logic? Logic is simply a statement that can be assigned a truth value. A statement that a truth value can be assigned to. That is, the statement can either be true or false. So any statement that has a truth value is considered to be logic in its simplest definition. So in this example, we are to compute the truth table for the following logical formula. Phi, here is phi. This is a Greek alphabet used in solving or giving logical equations. So we have phi to be equal to bracket A or bracket B and negative of C, bracket closes, double bracket, and double bracket B implying bracket C, by implication negative of A, bracket closes, or A, bracket closes, where psi, this is psi, where psi implies or equal to B implication of bracket C by implication negative of A. All right, so solution. So we are going to compute the truth table for this equation now, and then step one. Now, since we have three variables, we have three variables A, B, and C. A, B, and C. So let's identify the variables that we have. We have A, B, and C. These are the alphabets that are given to us. Okay. Then since we have three variables, our possible combination is going to be 2 raised to power 3, which is going to be 8. Okay, these are the possible combinations we're going to obtain from these three variables. Okay, so now we draw our table A, B, and C. Okay. Then we have 1, 2, 3, 4, 5, 6, 7, and 8 possible variables. Okay. So begin with 0, 0, 0. Yeah. Another possible combination we're going to obtain from this variable is 0, 0, 1, and then we have 0, 1, 1. So from our third combination we have 0, 1, 0. Then our fourth combination gives us 0, 1, 1. Then fifth combination gives us 1, 0, 0. The sixth is 1, 0, 1. Then the seventh is 1, 1, 0. Then the eighth combination is 1, 1, 1. Okay, yeah, we have done the first step, which is to compute the possible combinations for A, B, and C. Then the step 2, we are going to compute the negative of C and negative of A. Okay, so we're just computing C. We need C, and we need negative of A. Okay, we need C, negative of C, and then we need A, negative of A. For this, our step 2 now. Okay, but we know already that C has been given to us to be, okay, let's number it 1, 2, 3, 4, still 8 combinations, 3, 4, 5, 6, 7, 8. C has been given to us already. We have already computed C. From here now, the value of C is 0, 1, 0, 1, 0, 1, 0, 1. That's the value of our C. Then negative of C, 1 stands for 0 stands for false, and 1 stands for true. Okay, so if 0 is false, then negative of C is going to be the opposite of 0, which is true. So have 1. Then this one will give us what? 0. This gives us what? 1. This gives us 0. This gives us 1. This gives us 0. This gives us 1. Then this gives us 0. Okay, that's negative of C. Then A, already from step 1, this is our A. So I'm just going to write it. We have 0, 0, 0, 0. Basically, I have 4 zeros from A. Then we have 1, 1, 1, 1. Okay. Then negation is 1, 1, 1, 1, and then 0, 0, 0, 0. Okay. So that's our step 2. Step 2 is done. So in our step 3 now, step 3, we're going to compute B and negative of C. Okay, we're looking at this formula now. We're looking at this formula, B and negative of C. Okay. So here now, we need B, we need negative of C, negative of C, and then we now need B and negative of C. Now remember that this operator here means what? And. Okay, and when you are joining two words together, two words cannot be true or false at the same time. If one is false and the other one is true, then the whole statement is what? False. That is the principle that guides the use of this operator. And all right, so we need a B and negative of C. Already we have already computed these values. We have computed B. So from what we computed, we have 0, 0, B 0, 0, 1, 1, 0, 0, 1, 1, and the negative of C has been computed from our step 2 already. So negative of C is 1, 0, 1, 0, 1, 0, 1, 0. Okay, 1, 2, 3, 4, 5, 6, 7, 8. All right, so now so if one statement is false and another is true, that means the whole statement is what? False. If one statement is false and another one is false, then the whole statement is what? False. One is true. If B is true and negative of C is true, then we have the whole statement being true also. This will give us what? 0. This gives us what? 0. This gives us what? 0. This gives us what? 1. Then this gives us 0. Yes. Then our step 3 is completed. Then we move to step 4. Step 4, we are going to compute A or bracket B and negative of C. So we need A. So we need A for this operation, and then we need B and negative of C, and then we now need A or bracket B and negative of C. Already A is 0 0 0 0 1 1 1 1, and then from step 3 we have computed B and negative of 3. So what we've obtained was 0 0 1 0 0 0 1 0. Okay, then we're now applying this OR principle. This principle here, this operator here means either or. Okay, so as this is equal to either or, that's the either or operator, and it basically means that at least one of the statements must be what? True. Either of the statements must be true. So when you have A to be false and then this one here to be false also, that means the whole statement is false. So the truth value we have here is false. It applies here to false. Then here is what? True, because at least we have one statement that is what? True here. So this is true, and this one is what? False also, because everything is false here. And then here is what? True, because at least we have one statement that is true. 1 represents truth and then 0 represents false. So we have true here. We also have what? True here. Then here is what? True also, because both of them are true. So 1 must be true. Then we have also what? True here. Then step 5, we are going to compute C by implication of negative of A. This is an equivalence formula or equivalent operator in logic. So what we need here is we need C, then we need negative of what? A. We need negative of A, then we need C equivalent to negative of what? A. We'll draw the table. Already from our previous step, we have obtained C to be 0 1 0 1. So we have from 4 1, then 5 is 0, 6 is 1, 7 is 0, and then 8 is 1. The negation of A was obtained to be 1 1 1 1, and then 0 0 0 0. So the rule governing this by implication formula equivalence states that, okay, let's write it down. The equivalence is true if both values are the same, that is both, if both values are 0 or 1, so they are the same, otherwise false. Okay, so that's the rule of equivalence. If we have both values to be 0 or 1, for instance, if C is 0 and minus A is 0, then equivalence is true, that it has a truth value of 1, but otherwise it is what? False. So applying this rule now, we have 0 here, we have 0 because they have different truth value. Then we have, because they have the same truth value, we have 1 is true, then we have 0 here, then we have 1 here, we have 1 here, we have 0 here, we have 1 here, and then we have 0 here. So we have computed this equivalence here, or by conditional. I mean, from here, this is where we obtained this. Okay, then the next step we're going to take, we're going to compute, that is our step 6, right? That's step 6. Step 6. In this sixth step, we're going to compute B implication, or implying C by implication of negative of what? A. Okay, now let's write the rule for implication. So the implication B implying X is false only when B is 1 and X is 0, otherwise true. So with this, we'll now construct our truth table. We need B, we need C implication by implication, or equivalence of negative of A, and then we now need the whole formula B implying C equivalence of negative of A, which is actually our phi, or psi. Psi was given to us here. This is our psi. Okay, so we'll construct the truth table. We have this here. So already we have found our B to be 0. We found our B to be 0, 0, 1, 1, 0, 0, 1, 1. And then here, from here, we have computed this one already from our step 5. So give us 0, 1, 0, 1, 1, 0, 1, 0. Okay, so we apply this rule here. Okay, the rule states that B implying X is only false when B is 1 and X is equal to 0. So we'll check what we have here. Here we have, from our tree, we have B to be 1 and X here. This represents our X now. Present our X. So we have it to be 1 and 0 here. So here is going to give us 0. God is going to give us 0. And then from here also, the last one, we have 1 and 0 here. So we have 0. Otherwise, every other thing is true. Okay. correct. So this is what we have here. Okay, the last step we're going to, and the final, right? Step 7, we have to compute psi or a. Psi or a. Where does this come from? It's come from our initial formula here. We have a here already. We have a. So compute psi or a. So we need psi here. We have computed psi already. Then we need a. Then we need psi or a. So from our previous table, we have psi to be 1, 1, 0, 1, 1, 1, 1, 0. Okay. Then a is 0, 0, 0, 0, and then 1, 1, 1, 1. So psi or a, either of them must be true. So we have this is true because it has at least one truth value, so it's true. This one is also true. Then this one is false because neither of them has a truth value. This one is true. Yeah, true. This is true. This is true, and this one is also what? True. Okay. Then step 8. Step 8. Now we will compute the final formula which is a phi or phi equal to a or b and negative of c and psi or a. So for here now we need a or b and negative of c. Then we need phi or a. Then we need our phi here. So we have to draw our table. Already we have computed this to be 0, 0, 1, 0, 1, 1, 1, 1. And then this one too has been computed to be 1, 1, 0, 1, 0, 1, 1, 1, 1, 1. So this is going to be 0. Why is it 0? Because we are using AND. AND is the operator that is functioning here. When two statements are, one is true and one is false, then the whole statement is false. So the same thing applies here. We have 0 here. This one is also 0. This one is 0. Then here is true, 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 and true. Okay. So now we want to compare A and phi. For my initial, the initial value of a was, okay, let's say a and phi here. The initial value of a was 0, 0, 0, 0, 1, 1, 1, 1. And then for our phi is 0, 0, 0, 0, 1, 1, 1, 1. So we say since a and phi have the same, let's use since a and phi have same values, we now conclude that phi is equivalent to a. Okay, this is called, phi is called phi, and here this is called psi. Okay, that is Greek alphabet. Okay, thank you for being part of this video. Don't forget to like and share and comment. Thank you. Goodbye.